So section 1.8, other types of polynomial inequalities. The first inequalities is going to be the quadratic inequalities, or polynomial with degree 2. I'm going to show you how you're going to solve this problem, and then you're going to do exactly the same thing with other, because we need to find the solution. And the solution with inequalities always going to be interval notation. If you look to the first example, this is a quadratic inequality. Why? Because the highest exponent is 2. 2x squared minus 4 greater than or equal 0. It's an equality because we have a greater than or equal to the 0. That means our solution is not going to be x equal 5, x equal 6, x equal negative number. Our solution is going to be interval notation. So that means we need to find the interval where all the numbers, when you plug in here, all the x's, when you plug in here, is going to be greater than or equal to the 0. So the first thing, we need to find the key numbers. The key numbers for this inequality. What I'm going to do, we need to factor this side. So don't look to this equal, greater than or equal, factor this side. 2x squared minus 4 greater than or equal to the 0. I'm gonna get the GCF here. Do we have an x? Yeah, we have an x here. So the GCF is 2x, and the left is going to be x minus 4, x minus 2, greater than or equal to the 0. Now, next step, I'm going to solve this one. That means 2x greater than or equal to 0. On the other side is going to be x minus 2 greater than or equal to the 0. If you want to change the sign just to equal sign, is going to be fine, because these are called the keys number, the key numbers. So now solve this one, divide both sides by 2. That means x greater than 0. This is the first key number. On the other side, we're just going to add 2. So it's going to be x greater than or equal to, this is the second key number. Now, next step, what I'm going to do, I need to find the interval notation. I'm going to graph a line and put all these keys numbers, which is 2 key numbers. We have 0 and 2. So I'm going to put the 2 here, and here is the 0. Here's a dashed line, so I can know. Now I'm going to test each interval here. This is negative infinity, because this side goes to negative infinity, and this side goes to the positive infinity. I'm going to test this interval, and I'm going to test this interval, and I'm going to test the last one. So to test this interval, I'm going to choose a number here. Let's choose -1. To test this interval, choose a number between 0 and 2. Let's say 1. To test this interval, you can type it here, so you're not going to get confused. Let's type the numbers here, -1, and here is 1, and the other one is going to choose any number here is a 3. So here is the keys numbers, and I'm going to check each interval here by choosing a number, -1, -2, -3, it's up to you. Between 0 and 2, I'm going to choose 1. Between 2 and infinity, I'm going to choose a 3. Now let's plug in this number here. So if you are plugging -1 here, 2 times -1 squared minus 4 times -1, how much is going to be the result? Is the result greater than or equal 0? 2 -1 squared is going to be 1 times 2 is going to be 2 minus -4 times -1 is going to be +4. Is that greater than or equal 0? 2 plus 4 is going to be 6. which is greater than or equal 0. That means the first interval is going to be our solution, which is from negative infinity to 0. From negative infinity to 0 is our first solution. Let's check the second one. Plug in the 1 here. So it's going to be 2 times 1 squared minus 4 times 1. Is that greater than or equal to the 0? 2, 1 squared, 1 times 1 is going to be 1, times 2 is going to be 2. Minus 4 times 1 is going to be 4. Is that greater than or equal to 0? 2 minus 4 is going to be negative 2, greater than or equal to 0? No, that means this is wrong. This is not a solution. So that means from 0 to 2 is not the interval solution for this inequality. Let's check the 3. 3, plug in the 3 here. 2 times 3 squared minus 4 times 3. Is that greater than or equal to 0? 3 squared is going to be 9. 9 times 2 is going to be 18. Be careful. Do not multiply 2 times 3, then square. It's going to be wrong. Square the number, then multiply the result by 2. Minus 4 times 3 is going to be 12. Is that greater than or equal to 0? 18 minus 12 is going to be 6, which is greater than or equal to 0. That means this one is right. So our solution is going to be from negative infinity to 0, from negative infinity to 0. And here is the important thing. I have equal sign. That means equal to the 0. So I'm going to put a bracket here. Union from 2 to infinity. Here is 2 and here is the infinity. The same thing. The number is equal to the 2. So I'm going to put a bracket here. Because here's the key numbers. I forgot there's an equal sign here. It's equal to the 0. So I'm going to put a bracket here. And it's equal to 2. So I'm going to put a bracket here. If there is no equal signs here with the key numbers, that means you're going to put parentheses instead of these brackets. So let's plug in our solution here, which is, here, we can choose the bracket. And we're going to graph it also. So from negative, they didn't put infinity here. How are you going to get the infinity? You're going to get the Greek symbol. And it's supposed to be here, go down. Here's the infinity. So I'm going to put parentheses. Oh, here's only for the graph. Parentheses, comma, and now I'm going to put the bracket. I have to use this one also. To the 0 on the bracket. Union, you're going to find the union in here. Operations. On the sets. Here's the union, and you're going to open a bracket. 2, comma, infinity here. Then parentheses. There's 2 brackets. I have to delete this one. Okay, now it's right. Now to graph it, that's mean from negative infinity. No, I have to change until which number? Okay, let's delete this one. From negative infinity to 0. So here is the 0. I'm going to put a bracket here. And the solution is supposed to be to the infinity. Okay. And the second one is from 2. That means the other bracket to number 2. And the solution to the infinity, you're going to click on the infinity. So that's supposed to be our graph. Submit. That's it for this one. So the second one, x squared less than 49. And let's do exactly the same. So how are we going to solve this inequality? How are we going to solve this one? The only way to solve it, if you want to move the 49 to this side, then you're going to use difference between two squares, or you can take the square root for both sides. Both way is going to be right. So if you want to move the 49 to the other side, you're going to say x squared minus 49 less than 0. Then you can take the square, use the difference between two squares here. That's mean x under parentheses less than 0. Then put 7 here and 7 here. 1 plus, 1 minus. There's the x. So now we have two parentheses less than 0. That's mean x plus 7 less than 0 and x minus 7 less than 0. Solve this one, you're going to minus 7. So x is going to be less than negative 7. This is the first key number. And add 7. So x is less than 7. This is the second key numbers. This is not the solution. These are the keys numbers. Okay. So next step, you're just going to put line. This is infinity. And here's negative infinity. Then put down negative 7 here and 7 here. Sometimes you have three key numbers. We will see that with the next part. Now on the first one, here's the first key numbers. I'm going to put dash line here and the dash line here. It's up to you how you're going to do it. It's fine. The main thing, you have to pick a number from here and from this interval and from here. So from this side, I'm going to take negative 8. Here, the easiest one between negative 7 and 7, you can choose the 0. You can choose 1, negative 1, it's up to you. Well, 0 is the easiest number. Here, I'm going to pick 8. You can pick 9, 10, 11, 12, it's up to you because it goes to the infinity. Now, let's plug in this number here. If you plug in negative 8 here, it's going to be negative 8 squared. Be careful here. That's the important thing. You're not going to say negative 8 squared. It's going to be wrong. It's going to be negative 64. Put parentheses and square the whole number, which is negative 8. That means you're going to square the negative sign and the 8. Is that less than 49? Negative 8 squared is 64. Less than 49? No, this is wrong. That means this is wrong statement. That means this is not a solution. Let's plug in the 0 here. 0 squared less than 49? Yes, 0 less than 49. That means this is a solution. Here, the third part, 8. Plug in the 8 here. It's going to be 8 squared less than 49. That means 64 less than 49. No, this is wrong. This is wrong. That means our solution only between negative 7 and 7. How am I going to write down? There is no equal sign here. There is no equal sign here. That means the solution is going to be from negative 7 parentheses on this side because there is no equal sign, comma. There is no equal sign here. So I'm going to put parentheses. That means the solution is all numbers between negative 7 and 7. Negative 7 and 7. That's it for this example. Let's check here. We're just going to put two parentheses, negative 7, comma 7. To graph it, here is negative 7 And here is 7. Choose the other one. And I'm going to put line between these two. Just like this. Okay. You're going to click the raw line between these to show this is the solution between -7 and 7. That's it for this example. The difference between example 3 and example 2, I'm not going to care about the sign, which is greater than or less than, how to solve this one, how to find the key. If you look to example 2, I told you there's 2 ways to solve this one. The first one, you can move the 49 to this side and use the difference between 2 squared to factor the left side. Or you can take the square root for both sides. That means x is going to be less than plus or minus 7, which is the same thing. X less than -7 and x less than 7. So 2 methods to solve this example. For this one, if you want to move the 1 to this side, you have to FOIL the parentheses, then you're going to add the 1, then you're going to factor the result. It's going to be a long process. The easiest way for this example is to take the square root for both sides. So if you take the square root for x minus 7 squared less than or equal the square root for 1. Cancel the radical with the root, so it's going to be x minus 7 less than or equal plus or minus 1. Remember, always when you take the square root for any number, you have to put a plus or minus. That means we have 2 solutions. 2 key answers or key number. It's not a solution because inequality, that means we're going to work with intervals. Our solution is going to be intervals. That means here x minus 7 is going to be greater than or equal 1, and x minus 7 is going to be greater than or equal -1. Add 7 here, add 7 here. So x is going to be greater than or equal 8. This is the first key number, 8. Here, you're going to add 7. You're going to add 7. So x is going to be greater than or equal -1 plus 7 is going to be 6. Here is the second key number. Now, our next step, we need to test these 2 key numbers. So I'm going to do the line. Here is, I'm going to put the 6 here, and here is 8. 2 dash line. 2 dash line, I'm putting these 2 dash lines, so I'm not going to confuse myself. And I know this is the first interval, here is the second one, and here's the third one. This is goes to the infinity, and this side goes to the negative infinity. Now, how are we going to work on it? Just test a point from here, check 6, and go to the negative infinity. The easiest now, you can take 5, 4, 3, 2, 1. I'm going to take the 0 because this is the easiest number. Between 6 and 8, I'm going to take 7. By the way, you can take decimal number, it's fine, between 6 and 8. But why I'm taking decimal number? I'm just going to take a whole number, which is 7. And here we're going to take the 9. Let's plug in the first number here. Plug in the 0 here is going to be 0 minus 7 squared. Is that greater than or equal 1? 0 minus 7 is going to be -7. -7 squared. Is that greater than or equal 1? Yes. Why? Because -7 squared is 49, which is greater than or equal 1. So this is the first right interval from negative infinity to 6. Let's plug in the 7. Plug in the 7 here. It's going to be 7 minus 7 squared. Is that greater than or equal 1? 7 minus 7 is going to be 0 squared. Is that greater than or equal 1? 0 or greater than or equal 1? No, this is wrong. This is wrong. So this is not the interval solution. Let's plug in the 9 here. So it's going to be 9 minus 7 squared greater than or equal 1. 9 minus 7 is going to be 2 squared greater than or equal 1. 4 greater than or equal 1. So this is right. That's mean our solution, this part and this part. So we're gonna write down the interval. From negative infinity, always parentheses with the infinity or negative infinity, comma, 6. I'm gonna look to the 6, there's equal sign. So I'm gonna put the 6 on a bracket from this side. Union with the 8, also there is equal sign. So I'm gonna put also bracket from 8 to infinity. So this is our solution. It's going to be all the numbers from negative infinity to 6 and from 8 to infinity. So we're gonna put parentheses, negative infinity, comma 6, and the bracket. That's the hard part. Make sure it's only union bracket from 8, comma to infinity, and put parentheses. Now let's graph it from here is a bracket to the 6 and goes to the infinity. And another bracket here goes to the positive infinity, and that's it. So let's work on example 5, which is x squared less than 5 minus 4x. You do exactly the same process and always do the same steps. So let's work on example 5. It says x squared less than 5 minus 4x. 5 minus 4x. Now, how are we going to work on this one? Move these two numbers to the left side. So you're going to add minus 5 and add 4x to the both sides. So it's going to be x squared minus 5 plus 4x less than 0. Then I need to write down this from the highest order to the lowest one. So it's going to be x squared plus 4x minus 5 less than 0. Now this is a quadratic. How I'm going to solve the quadratic? I need to factor this side to get the key numbers. So I'm going to open two parentheses, less than 0, 1x, 1x, 5, which is 5 times 1. So I'm going to put 5 here and 1 here. Positive, negative. Let's check 5x. And here's negative, negative x. Add these together is going to be 4x. This is just to check which is the middle term. That means these are the key numbers. So in this case, we have x plus 5 less than 0, and the second key number is x minus 1 less than 0. Minus 5, minus 5. So x is going to be less than negative 5. And here we're going to add 1. So x is going to be less than 1. So we have two key numbers. And always when you write down the key numbers on the line, you're going to write down from the smallest one to the largest one. So the first key numbers is negative 5. And here is 1. Let's work. Pick a number from here. I'm going to pick negative 6. Number between negative 5 and 1. The easiest one is the 0. And the number is here. Let's take 2. Plug in negative 6 here. So it's going to be negative 6 squared less than 5 minus 4 times negative 6. Negative 6 squared is going to be 36 less than 5. Negative 4 times negative 6 is going to be positive 24. Now 36 less than 5 plus 24 is going to be 29. 36 less than 29? No, this is wrong. And this one is wrong too. Let's go to the second one. 0. Plug in the 0 here. Is the 0 squared less than 5 minus 4 times 0? 4 times 0 is going to be 0. That means 0 less than 5. This is right. So here's our first interval solution. Let's pick 2. Plug in the 2 here. So it's going to be 2 squared less than 5 minus 4 times 2. 2 squared is going to be 4 less than 5 minus 8, because 4 times 2 is going to be 8. 4 less than 5 minus 8 is going to be negative 3. This is wrong. That means this is not a solution. That means our solution between 5 and 1. How to write down? Look to the key numbers. There is no equal signs. That means the solution is going to be negative 5, comma 1. Parentheses from both sides. So you're going to go ahead here on 2 parentheses, negative 5, comma, and 1. And to graph it, here is negative 5, and here is the 1. Parentheses, draw a line between these 2 parentheses. That's it. Just a hint. For example, 4, you're going to move the 6 to this side. You're going to add it with 2, so it's going to be negative 4. Then you're going to factor this polynomial. So you're going to do the same steps. That's it for example 5. The only difference between example 6 and the previous examples is this is not a quadratic. It's higher order inequalities. Let's check how we're going to solve this one. So example 6 is going to be x squared, x cubed minus 2x squared minus x plus 2 greater than 0. There is no equal sign. Okay. So now we have 2 ways to solve this one. You can use synthetic division or check, can I use the factoring by grouping because I have 4 terms. And factoring by grouping, we can use it when we have 4 terms. If not, you have to go to use synthetic division. So let's check with this one. So I'm going to group the first two terms, and I'm going to group the second two terms. Now, what's the common between the first two terms is just the x squared. The left is going to be x, because the cubed, minus 2 is going to be 1, minus 2, that's what the left. Here, the common between this one, there's no common between this one, only the negative sign. I can take the negative sign out. So here's the negative sign. Now, negative 1 divided by negative is going to be 1. That means just x. And 2 divided is going to be minus 2. That means this one similar to this one. So it's going to be x minus 2. And here is x squared minus 1 greater than 0. That means we have is going to be 3 key numbers here. So what I'm going to do, say x minus 2 greater than 0. And here x squared minus 1 greater than 0. Solve this one. You're going to add 2. So x is going to be greater than 2. Here is the first key number. Here, if you want to add or you want to do the difference between two squares, it's going to be the same. That means x plus 1 greater than 0. So x minus 1 greater than 0 and x plus 1 greater than 0. Or you can factor it from here and you're going to get 2 parentheses. It's going to be the same way. You're going to add 1. You're going to minus 1 here. So here is going to be x greater than negative 1. And here is going to be x greater than 1. So we have 3 key numbers. So now we need to test these 3 key numbers to find our interval solution. So I'm going to put here, we have a 3. Careful, 3 key numbers. Not 2. So here is negative 1, the smallest number. And here is 1. And here is 2. So we need to test this interval. And this one. And this one. And this one. So you see how many intervals we need to test? 4 intervals. Let's move the 2 a little bit so we can get space. Now let's plug in negative 1 here. And that's the important part with higher order inequality. So plug in negative 1 here. That means it's going to be negative 1 cubed minus 2 times negative 1 squared minus negative 1 plus 2. Is that greater than 0? Let's check how much is going to be the result. Negative 1 cubed is negative 1 minus negative 1 squared is 1 times 2 is going to be minus 2. Negative times negative is going to be plus 1 and the plus 2. Negative 1 cancel with the 1. 2 cancel with the 2. The result is 0. Is that greater than 0? 0 greater than 0? This is wrong. That means we can't say 0 greater than 0. It's only equal. So this is not an interval solution. Negative 1 and 1. Let's pick a number here. I picked the 0. I forgot to tell you I picked the negative. We can't pick negative 1 here. We have to choose different numbers because we need to test this one. Let's pick negative 2. Let's pick negative 2. Let's plug in negative 2 here. That's mean negative 2 cubed minus 2 times negative 2 minus -2 plus 2. Then -2 cubed is going to be 8, -8. -2 times -2 is going to be plus 4. Negative times negative is going to be plus 2 and a plus 2. Is that greater than 0? -8, and this is 8, so it's going to be 0 greater than 0, which is the same thing what we got before. That means this is not a solution, this is not an interval solution. Let's go to the next one. Pick the 0, plug in the 0 here. So it's going to be 0 cubed minus 2 times 0 squared minus 0 plus 2. Is that greater than 0? This is 0, this is 0, and this is 0. 2 greater than 0? Yes. So this is the first interval solution. Let's check the third one. You're going to pick a number between 0 and 2. Between 1 and 2. In this case, there's no whole number between these two intervals. So in this case, I'm going to pick 1.5, 1.2. So a 1.5. Let's choose 1.5. Plug in 1.5 here. It's going to be 0.5 cubed minus 2 times 0.5 squared minus 0.5 and the plus 2. Let's check how much is going to be that. Be careful here because you can't pick a whole number. And always when you pick numbers, go ahead, use the calculator so you're not going to do a simple mistakes. So here is going to be parentheses 0.5 cubed and minus 2 times 0.5 squared and minus 0.5 and plus 2. So it's going to be 1.125, which is greater than 0. So that means this is also a solution. Wait a minute, we have 1.5. Why I put 0.5? It's 1.5 cubed. So 1.5, not 0.5. The result is going to be negative. (1.5 cubed minus 2 times 1.5 squared and minus 1.5 plus 2. The result is going to be negative 0.625, which is not greater than 0. That means this is not a solution. The third part, we're going to pick 3 to test number 3. So it's going to be 3 cubed minus 2 times 3 squared minus 3 plus 2. Let's check. We're going to do the same thing. 3 cubed minus 2 times 3 squared minus 3 plus 2. It's going to be 8. 8 is greater than 0. So this is also the solution. So now, next step, we're going just to write down from this here and here to infinity. -1, parentheses. 1 is also parentheses. So the interval is going to be -1 to 1, parentheses from both sides, union from 2 to infinity. This is the interval. So that's how we're going to work if you have 3 key numbers. So let's plug in the numbers here. That means we have parentheses from -1 to 1, -1, comma 1, and union, another 2 parentheses, which is 2 comma, and infinity. So it's going to be parentheses from -1 to 1. Here is -1, and here is 1. We're going to draw a line here, and from 2 to infinity. So another parentheses from 2 to infinity. That's it for this example. So this one is exactly like example 7. Let's work on this one, just different numbers. So the first step, we're going to move the 60 to this side. So it's going to 2x cubed plus 15x squared minus 8x minus 60 is going to be equal 0. If you look to this side, we can't factor it by using factoring by grouping, because here is the common is -4, and here is the common is x squared is not going to common between these two. So let's use the synthetic division. Even if you can, I'm going to use the synthetic division. So we already know A naught is going to be 60, and AN is going to be 2. P is the factors of A naught, which is the 60. Let's find the factors of 60. Again, how are we going to do the factors of 60? First of all, plus or minus 1. And then plus or minus 2, because 2 times 30, plus or minus 3 times 20. So, because 60 divided by 3 is going to be 20. So 3 times 20. And by 4, 60 is going to be 15. By 4 is going to be 15. That means 3 plus or minus 4 plus or minus 6. 6 times 10. And plus or minus 6, 7, you can't, because 60 divide, no, just divide by 7, you can, is going to be the decimal number. 8, you can't. Check it, 60 divided by 8 is going to be decimal. 9, you can't. 10, you which is 10 times 6, so 10 plus or minus, if you can try, by 12, also you can't. 5. So we have to add the 5 here. So we have to add the 5, because 5 times 12 is going to be 60. So I'm going to add the 5 here, and I'm going to add the 12, and I'm going to add the 15, and I'm going to add the 30, and then the last one plus or minus 60. This is the factors of P. The factors of Q, which is only 2 numbers, plus or minus 1, and the plus or minus 2. Now let's find the possible zeros, which is P over Q. It's exactly what we used to be doing on the previous section, because we need to factor this polynomial. So it's going to be all these numbers over 1 and all these numbers over 2. So it's going to be a lot of possibles zeros. It's going to be plus or minus 1, and the plus or minus 2, and the plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6. 5, I just add down the 5 first, plus or minus 10, plus or minus 12, plus or minus 15, plus or minus 30, and the plus or minus 60. I have to keep going. Now all these numbers divide by 2. So we have to keep going. Plus or minus 1 divided by 2 is going to be half. 2 divided by 2 is going to be 1. It's going to go back here. 3 divided by 2. 4 divided by 2 is going to be 2. We already have 2. 4 divided by 2, 2. 6 divided by 2 is going to be 3. 10 divided by 2 is going to be the 5. 5 divided by 2. So 5 plus or minus 5 divided by 2. And 6 is going to be 3. 10 is going to be 5. 12 is going to be 6, because 12 divided by 2 is going to be 6. 15 divided by 2, so plus or minus 15 divided by 2. And 30 divided by 2 is going to be 15. And 60 divided by 2 is going to be 30. So that's it. This is all possible zeros. Now let's start. We're going to pick 1, -1, 2, -2. Because I'm going to start from the first one, I'm going to pick the 1. So I'm going to say if k equal 1, I'm going to write down all coefficients here, which is 2, 15, -8, and -60. So the first number is going to be 2. 1 times 2 is going to be 2. Add these two numbers is going to be 17. 1 times 17 is going to be 17. Add these two numbers is going to be 9. 1 times 9 is going to be 9. Add these two numbers is going to be -51. It's not 0. The remainder is not 0, so I'm not going to choose this one. I'm going to choose k equal -1. And check if it's going to, we're going to get a remainder equal 0, 2, 15, -8, and -60. Here is the 2. -1 times 2 is going to be -2. Add these two numbers is going to be 13. 13 divided by -1 is going to be -13. -1 times 13 is going to be -13. Add these two numbers. It's going to be negative. Yeah, it's going to be -21. Multiply these two numbers. Is going to be +21. And add these two numbers is going to be 39. Also -39 is going to be not equal to the 0. So I'm not going to choose k equal -1. I'm going to move to the next one. I'm going to choose k equal 2. And let's see when k equal 2. When k equal 2, here's 2, 15, -8, and -60. So here's 2. 2 times 2 is going to be 4. Add these two numbers, it's going to be 19. 2 times 19 is going to be 38. Add these two numbers, it's going to be 30. Now 2 times 30 is going to be 60. Add these two numbers, it's going to be 0. That means the first factor is going to be x minus k, which is equal x minus 2. Equal x minus 2. That means this side is going to be x minus 2, and the other side is going to be, this is x squared, this is x, and here is constant. So it's going to be 2x squared plus 19x plus 30, and it's going to be greater than or equal to the 60. Here's a mistake here. This is greater than or equal. So now this is easier to factor. So I'm going to say x minus 2. And here, which is going to open two parentheses, greater than or equal 0, which is the other side. I'm going to say here's 2x, and here's x. Then 30 is 15 times 2. So I'm going to put 15 here and 2 here, plus and the plus. Now this one is going to be 15x, and this one is going to be 4x. Add these together, is going to be 19x. So here is the factors, or here is the answer keys for this polynomial or inequality. So the first key is going to be x minus 2 greater than or equal 0. You're going to add 2 to both sides. So x is going to be greater than or equal 2. Here is the first key. The second key is going to be 2x plus 15 greater than or equal 0. You're going to move the 15. Cancel here. So 2x greater than or equal negative 15. Then you're going to divide by 2. So x is going to be greater than or equal negative 15 over 2. And this, the last one, the last key is going to be x plus 2 greater than or equal 0. You're going to say, well, here's minus, here's a plus here. You're going to say minus 2. That means x is going to be greater than or equal negative 2. So we have 3 key numbers. This is only to find the key numbers. So negative 15 over 2, which is negative 7.5, you're going to put it here, then negative 2, then 2. Then we're going to pick numbers from each side and plug in these numbers in our polynomial. So I'm going to write down the polynomial here so we can use it, which is 2x cubed plus 15x squared minus 8x minus 60 greater than or equal to 0. I'm going to use this one. This is negative 7.5. So I can choose negative 8 here. Between negative 7.5 and negative 2, I can choose negative 3. Between negative 2 and 2, I can choose the 0, the easiest number. And here I can choose 3. So 1, 2, 3, 4. 4 test points. So let's plug in the first one. So when we have negative 8, plug in negative 8 here. So it's going to be negative 8 cubed. Keep going, plus it's 2 times negative 8. 2 times negative 8 cubed. Plus 15 times negative 8 squared. Minus 8 times negative 8. Minus 60. The result is going to be negative 60. So negative 60 greater than 0, this is wrong. That means this is not a solution set. We can go to the next part. Let's plug in negative 3. Negative 3, so it's going to be 2 times negative 3 cubed plus 15 times negative 3 squared minus 8 times negative 3 minus 60. It's going to be 45. 45 is greater than or equal to 0. So this is the first solution set between negative 15 over 2 and negative 2. Let's go to the second one, 0. If you plug in 0 here, this is 0. This is 0. This is 0. It's going to be just negative 60 greater than 0. Negative 60 greater than or equal to the 0. This is wrong. This is not a solution set. Plug in the 3. 3 is going to be a positive number. 3 times 3 cubed plus 15 times 3 squared minus 8 times 3 minus 60. The result is going to be 105. 105, which is positive number greater than or equal to 0. So this is also right. So the solution set in this case is going to be from this number to this number. And if you look to the key numbers, all equal sign. So with 2, we're going to put bracket. With negative 15 over 2 bracket. With negative 2 is going to be bracket. Between these two numbers, so it's going to be bracket. Negative 15 over 2 to the negative 2. Also bracket from this side, union. Bracket with the 2 and goes to the infinity. So this is our solution set for this example. Let's check that. So it's going to be bracket. I need to write down fraction. Negative 15 over 2, comma, to the negative 2, bracket. Then we're going to put union, another bracket, 2, comma, and to the infinity, but now we're going to put parentheses. Careful here. Pause. Okay, now I'm going to graph it. Negative 15 over 2 is going to be 7.5. Negative 6 and 7.5. So it's going to be, we can graph it here. Bracket, here is negative 7. 7.5 is going to be here. Let's do it here. And negative 2 with a bracket also. Here is negative 2 with the bracket. And the second one is from 2 to the infinity. We need to draw a line here. Oops. Between these two. Okay. And let's check. Here we go. It's wrong. Let's check. Oh, because I'm solving different one. Okay, that's why. So that's why it's wrong, because I solved different examples. So I can't plug in the answers here. Let's go to the next one, because you're going to get exactly the same one. Example 8, you're going to do the same thing. You're going to factor this polynomial. And let's work on this example. 4x cubed minus 6x squared less than 0. Example 8, which is 4x cubed minus 6x squared less than 0. How are we going to solve this one? The only way to solve this one, you can use standard division, but can I find the GCF? Yes, there is GCF between x cubed and x squared, 2 and 4 and 6, which is 2x squared. So 2x squared as a GCF, the left is going to be 2x minus 3, less than 0. Now, 2x squared from this side, 2x squared is going to be less than 0. And here is 2x minus 3 less than 0. Solve this side. divided by 2 is going to be x squared less than 0. That means x less than 0. Here, we're going to add a 3. So 2x is going to be less than 3. That means x is going to be less than 3 over 2. So here is the two key answers. 3 divided by 2 is going to be 1.5. That means when you grab the test line, you're going to put 1.5. So 1.5 and 0. So here is the 0. And I'm going to put here 1.5. That means 3 over 2. The first test number is going to be on this side. Let's take -1. Between 0 and 1.5, which is a 3 over 2, 0 and 1 point, we can take the 1. 1.5, that means I can take 2 here. Let's plug in these three numbers here. -1, plug in -1 here. That's mean 4 times -1 cubed minus 6 times -1 squared. Is that less than 0? -1 cubed is going to be -1 times 4 is going to be -4. -1 squared is going to be 1 times -6 is going to be -6. Is that less than 0? So -4 minus 6 is going to be -10, which is less than 0. So this is right. So the first interval solution is going to be this one. The second one is going to be 0 to 3 over 2. So I'm going to pick the 1. Let's plug in the 1 here. That's 4 times 1 cubed minus 6 times 1 squared less than 0. 1 cubed is going to be 1. 4 times 1 is going to be 4. -6 times 1. 1 squared is 1. -6 is going to be -6. Is that less than 0? Yes, because it's -2 less than 0. So this is also a solution set. The third one is just bit number 2. So 4 times 2 cubed minus 6 times 2 squared. Is that less than 0? 2 cubed is 8. 8 times 4 is going to be 32. 4 squared is 2 squared is going to be 4 times 6 is going to be 24. Is the result is less than 0? No, because 32 minus 24 is going to be 8, and 8 is positive number, not less than 0. So this is not a solution. This is not a solution set. So now our interval solution is going to be from -infinity to this number. We're going to put parentheses here, because look, the first key numbers is union. We're going to put the second number, which is also from 0 to 3 over 2. Parentheses from this side. Or you can merge these together from -infinity to 3 over 2, because the same interval, but except the 0. So keep it like this, because there is no equal sign. So we can't merge these together, because there is no equal sign but the 0. That means all numbers except the 0. So we're going to type here 2 parentheses from -infinity, comma to 0. And we're going to put here union from 0, comma to number 3 over 2. Operation 3 divided by 2. And which one is going to be the right one? From -infinity to 0. So this is from -infinity, and this is the 0. And it says from 0 to 3/2, which is 1.5. So this is the right one. Submit. That's it. Next one, you don't have to factor it. It's already factored. So example 9, you don't have to factor this one. You're just going to say x minus 5 greater than or equal 0, and x minus 4, x plus 4 greater than 0. Solve both sides. You're going to get the key numbers. Then you're going to do exactly the same steps here. Test, line, and that's it. For example 10, you're going to do exactly the same thing. You don't have to factor it. It's already factored. So x4 less than or equal 0, and x minus 5 is going to be less than or equal to the 0, and solve both sides. You're going to get the same result. This one, you're just going to check if you can solve this one. This is important example. Then we're going to go to the next part, which is the rational. But this example, you can't factor it. You have to use a quadratic formula. So when you use a quadratic formula, you're going to get a complex solution, complex number key as a key numbers. And you can't graph the complex key numbers. It's hard to find the solution here. So in this case, just gonna say there is the solution set is an empty. Or is there an option no solution? Yeah. No, that's the only thing you can choose, because you can't factor this quadratic equations. You have to use a quadratic formula. And I can't graph a complex number because our key numbers is going to be complex number. That means we can't graph it on the line. So there is no key numbers. The solution set is empty. That's what we're going to choose. Now the reason why, because you're going to use quadratic formula.